Greetings, Lutheran High. This is Cara Dune. This is Cara Dune. I'm amazing. I'm super tough and blow stuff up. So you should be like me and become smart and learn your math. So let's do some math. So we are on 9.3. 9.3, check on learning. So, starts off, explain how you can use ratios to determine whether or not an exponential model might be a good fit for a data set. If the ratios, because remember we took ratios earlier, of the function values for consecutive integer x values are the same or similar, then an exponential model is likely a good fit for the data set. So we can check our answer, not with that one. Ratios, the same or similar. I like the other check on learning that let me actually check the answers in front of you, but whatever. Use the information in the table to create a best fit exponential model for the data set. So it didn't say use a graphing calculator, so we're going to do this one the old-fashioned way. So remember, we were taking ratios, right? So, if this is our f of x, or our t, this is going to be, that's all wrong. That's all wrong. So this is going to be our t, and this would be like our f of t. Looks like we're doing year, painting, sold. So if we did, so we're going to say 2009 is equal to t equals 0. That should be a t. T equals 0. So then if we take f of 1, so that would be like 2010, over f of 0, that's going to equal 12 divided by 9, which is something cute and adorable, right? 6, so if I pull a 3 out, then it's going to be 4 over 3. I don't know why I went up, but whatever. Okay, so that's f of 1 over f of 0. So now we can do f of 2 over f of 1. And that's going to be 15 over 12. Again, let's take a 3 out. It's going to be 5, 4. Not the exact same ratio, but let's see what else we get. So then f of 3 over f of 2. So let's see, where am I? I didn't pick my t's very well. Anyway, f of 3 is 0, 1, 2, 3. So here we are. 25 over 15. So then we reduce, I can take a 5 out of that. It's going to be a 5 over 3. And let's just take one more, and then I'll probably convert it all into a decimal and see what happens. So there I am. So that's f of 4 over f of 3. So f of 4 is 38 over 25. Let's see, what can I take out of that? We're just going to convert them all over to a decimal and see what happens. So let's see here. 4 divided by 3, 1.33. 5 divided by 4, 1.25. I have an advertisement for TikTok on my calculator, which is annoying. 5 divided by 3, 1.6. It's 1.6666, so 1.67. 38 divided by 25, 1.52. And if I was really good, I would do all of them. But you'll see that they're all kind of pretty close to the same number. So we're going to then take an average of that. So we're just going to take, so I'll do my average in blue, 1.33 plus 1.25 plus 1.67 plus 1.52 all over 4. So that's going to equal where's my numbers? 1.33 plus 1.25 plus 1.76, 1.67 if I want to read correctly, plus 1.54 divided by 4, and our average we're going to call 1.45. Round the base of the nearest tenth, so it would be 1.5. So it's just going to be 1.5 x t, who knows what variable they're looking for. So let's see what they are looking for. So 1.4, that's what we got. I'm looking for the x. So we rounded ours a little bit differently. That's okay. And then that 9 is, if you look at your f of 0 right here, so f of 0 is going to still be equal to 9. And so that's why that 9 is in the front there. So don't forget that, like I tried to do. So again, that f of 0 is what's going to help you find your a, quote unquote. Next up, use a graphing calculator to perform an exponential regression on a data set. What is the exponential regression? Round each value to the nearest hundredth. Okay, so I'm going to write these values on the screen so I can transfer them over to the calculator. Oh, these are the same ones from before. I should have entered them in then. So anyway, I'm going to change this to t equals 0, 1, 2, 3, so on and so forth. Just an FYI. So 0, 1, 2, 3, 4, 5, 6. 9, 12, 15, 25, 38, 49, 58. All right, so we go back over to our calculator. Let's see if I pull up a different calculator. Nope. Anyway, so here's our calculator. Remember to enter our data points. We're going to go to Stats. We're going to Edit. We've got our two lists. So first we're going to clear them out. My 0 to 5. So I need that to go to 6. So that list is ready. And then we just have to enter this in. Just entering numbers. Okay, so we've got our list done. And so we go back to our stats. So we're going to go to calculate. So I pushed over. And we know that this is an exponential growth thing. So we want exponential regression. And list 1, list 2. And let's fire away. So there we go. We got A equals 8.7, blah, blah, blah. So let's write those down. 8.77. B is going to be 1.395. I think they said to the nearest tenth, but let's check. Enter the expression that correctly completes the model in the box. Round each value to the nearest hundredth. Well, I'm glad I wrote those down. I'm going to check my 8.77 real quick. Yeah, okay, I did round that correctly. And so here we go. Enter the expression in the box. 8.77, 40. So we rounding to the nearest hundredth. That goes up to 10, so that's why I did 40. And X. Okay, so let's check that, make sure we're right. Yep, we are right. I figured we were, because it was pretty close to this last one, so that would make sense. Okay. Here comes my puppies. I'm going to leave that equation on the screen. So you are given the best fit exponential model, y equals that. The exponential regression model is that for the data set in the table. This is all the same data, so that's convenient. Consider if the models are similar, which model better fits the data, and how do you know? So we can look on our calculator. So let's get rid of this. So I need to turn on that list. Oops. So remember, that's under stat plot. That's my bad, I forgot. So that stat plot is off. We are going to turn it on. And let's change the color. Let's make it red. So in our y equals, we can put in this formula, the one that's still on the screen, 8.77, 1.4 power of x. And I skipped one because I want it to be black. So that other one was what? 9 and 1.4. 9, 1.4. I'm assuming the regressive model, it's the blue one, is going to be better because it's actually based on the data. And here we go. Where's my... Okay, I think I figured it out. So we just got to fix our x and y. I think it was our y that needed to be a little bit bigger. So that should go up to like, our biggest value is 58. So let's make it go up to 70. So let's clear that other stuff off the screen. So what had happened was, so we have our two y values. I'm sorry, y equals equations. And over here under stat plot, we had our L1 and our L2 list reversed. So always make sure that you know what your calculator is doing. It'll only do what you tell it to. So, what was the question? Consider if the models are similar. Which model better fits the data, and how do you know? Okay, so let's look at our calculator again. Man, I don't know. So the black one is on top. I don't know, let's zoom in, see what happens. I just zoomed in a bunch. So we'll zoom back out. And I don't know, they're both the same to me. I don't know. Models are similar to one another. The best fit exponential model fits the data slightly better because the data points are more equally distributed. Sure. Models are not similar to one another. That's false. Models are similar to one another. The exponential regression model fits the data slightly better because the data points are more equally distributed on either side of the graph. So I would say the regression model, that's the one that's based on the data. So let's see what they said. They said the exponential regression model fits the data slightly better. As opposed to the exponential model. That's what I said, right? Yeah, the exponential regression model. So there you go. Last but not least, so it says use the model, what we've been working with, to create a logarithmic model that gives the time it takes the number of paintings sold to reach a certain number. So again, we have a y equals blah 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 x. We want to change that to a blah 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 y equals x. So this is where they did that trickery on us. So we know that we need to get this x out of the exponent. So we know that we're going to be taking a log of something. So why not use natural log, right? And look, down here in the answer there's a natural log. So we need to figure out how to express this, oops, pen's not working, this as a log. Okay, cool. So, or I'm sorry, not a log, but using e. So we have e to some constant equals 1.4. So we can take the natural log of both sides. So natural log of e to the power of c is c. So then that's natural log of 1.4. So we can shove this number into a calculator, wherever my calculator went. There's our last problem. So natural log, most scientific calculators should be able to handle this. So then we're going to have 0.336. So all of that equals 0.336. Okay, now what? So we've got our new equation, y equals 9 times what? E to the power of 0.336 raised to the power of x. So now we can, well, before we want to take the natural log of both sides, we should probably get this 9 over. So we've got y over 9 equals e to the power of 0.336x. So now we're going to take the natural log of both sides. So we're going to have natural log of y over 9 is equal to, again, natural log of e cancels out, 0.336x. So now we're going to divide this by both sides. 0.336, and there's a 1 over here. It's an implied 1. So then we can, again, go to our calculator and say 1 divided by 0.336 is going to give us another fraction. So we can say this whole equation equals 2.976 natural log of y over 9 equals x. So approximately, we should say. We did do some rounding. So as soon as we converted this into a decimal point here, we rounded. So x is approximately, it says nearest tenth, 2 or 3.0 natural log of y over 9. Whoops. So let's see what they got. 3.0 natural log y over 9. So the trick here is this part right here. So if you can remember that when you see this exponent and you want to get rid of that exponent, you're just going to have to use a natural log. That's going to help you. Again, you theoretically can do it with log base 10. I think just typically the math community likes to do it with natural log. So, I don't know. So, on that note, Cara Dune, you got anything left? No, Mr. Lin! Cara Dune, out! Don't forget! Star Wars is awesome. That's all I got. Bye!